Okay, we're having a little trouble getting started solving this system, okay? Now, again, we want to annotate everything we're doing. So here's equation one, here's equation two. Now notice if I do this operation, 4 times equation one, 3 times equation two, what two equations do I get? Okay, now multiply this equation by -1, means we've got to multiply both sides by -1, by -4. Multiply this side by -4 and this side by -4, emphasizing we have to use a distributive law, -4 times this whole side. Okay, so I'm going to have to assume that people understand that you just multiply every number here by -4. And that is the same as applying the distributive law. And then you distribute multiplication by -3 through both sides. And you get 12x. And 3 times 4 is 12, so you get 12y. And 3 times -3 is -9. Okay, so now what do we get? Well, people said, why do you do that? Why did you do what you did? But then they did it and they understood. Okay, so that's exactly the strategy that I had in mind, and it works. The 12x's, -12x and 12x add up to 0. Now, and the question that I got, it was a good question. Why did you multiply this one by 4 when there's a 3 here? And why did you multiply this one by 3 when there's a 4 here? I said, well, just do it and you'll understand. Okay, so we simply multiply each equation by the number in front of x and the other equation. Okay, that always works. It always ends up giving us the product of the same two numbers, and we use a negative when necessary, as it is in this case, so we don't have to worry about subtraction. Okay, so then 20y and 12y adds up to 32y. Everybody's good here. Okay, and now we complete the solution. So let's see how everybody's doing. Okay, so we solve this for y. We get y equals -37 over 32. Put 3 dots here to indicate that there's a step that I've skipped that I don't want people to skip, where you divide both sides by 32. Because we need to keep reinforcing that, because I find that it's still a significant proportion of a pre-calculus class doesn't completely understand those rules. We need to keep reinforcing those rules. Okay, so everybody did quite well understanding that we take this and substitute it into one of the equations, one of the original equations, and solve for x. Okay, so I'm just using arrows here to indicate what I'm doing. Okay, so we're going to substitute this for x, and that's going to give us an equation. Here we get 3x minus 5 times -37 over 32 equals -3, equals 7, sorry. We got the wrong equation. Okay, so I want to proceed to solve this. Now, as I've said, we're dealing with fractions here. We're not going to use the calculator and convert everything to decimals, although it's fine to do that to check your final solution. What I need to see is the fractions. So we've got this. Now, how do we deal with the fractions? Okay, so at this stage, well, first we're going to multiply -5 times -37 over 42. We're going to get 3x plus 185 over 32 equals 7. Now you got a couple of choices. you can subtract 185 over 32 from both sides. Okay. Or you could do the thing that I've said about 10 million times during the course. You've got a denominator, multiply both sides by that denominator. And that's what I'm going to do. Because if you put 7 over common denominator, it's kind of more of a pain than it is to simply multiply everything by 32. And now these numbers aren't that bad. 32 times 3x is 96x. 32 times 185, of course, is 185. And 32 times 7 is 224. If I've done my arithmetic correctly. So this is easy to solve. We subtract 185 from both sides. Get 39 over here. So let's get started. Bring this over here. We're going to get 96x equals, I believe this is 39. So I have 40 to 185 to get 225. So that's all right. So we get x equals 39 over 96. Okay. And I really think that's easier. It's less fraught with danger than trying to put 7 over common denominator. I mean, you get 224 over 32. It could work out, but it's just, the arithmetic's a little more complicated. It's very simple, just to multiply through by 32 through your denominator. Then you don't have to worry about any fractions at all until this last step where you divide and get a fraction. Okay, well, now 39 over 96 reduces to 39 divided by 3 is 13. 96 divided by 3 is 32. Now, if you want to approximate these, that could be useful. If you want to sketch a graph of these two linear functions and compare with your solutions. So I'm going to say that now you do this with your calculator and get it really accurate. But this is about negative 1.16 or something like that. And this is approximately 0.4. If I did my arithmetic correctly, which is always suspect. Okay. Now, if I want to draw a graph of these two, because your homework is going to ask you to solve these things by elimination, solve them by graphing, even solve them by substitution. So you have all three methods. Elimination is the one I'm going to emphasize here because I think the graphing and so forth, if you know how to graph a linear function, it won't be very difficult for you. Okay, well, my x-intercept occurs when y equals 0. If y equals 0, we get 3x equals 7. So x is 7/3. So y-intercept, if you can't immediately reason out and get the x and the y-intercept of an equation like this, you want to review that because you're going to have to do that. Okay, you have problems that go all the way back to linear functions, and that's the way. That's one of the valid ways of graphing the thing. Doesn't always work. Sometimes you got to use a known point in the slope, like point-intercept function. Okay. Anyhow, the y-intercepts are going to be, well, when x is 0, y is going to be negative 7/5. And if you want to approximate this, it's approximately 2.30 This is approximately 0, -1.4. I had to write that way too small, but you can use the approximations. And I'm writing all this small because it's something you should be able to do very easily. Second equation, x-intercept is -3/4, 0, like -0.750, and the y-intercept is 0, -0.75. So I figure those numbers out so I know how to scale my graph. Okay, I don't need numbers much bigger than 2. And I don't want to go much bigger than 2 because 0.75 gets kind of small. But I'm going to put 4 out here. And then this will be 2, here's 3, and here's 4. And then similarly on the y-axis. Okay, and I'll do the same thing up here. I'll put 4 here. So here's 2, here's 3, here's 1. Here's -4. Here's -2, -1, -3. Now I can locate these points. 2.30 would be about here. And 0, -1.4 would be about here. So here's my line. I can save the label here. 3x minus 5y equals 7. And then this line has x-intercept -7.50 and y-intercept 0, -7.5. That would be like here and here. So my line sneaked down a little bit too low, so I'm not going to get a great estimate here, but we're still going to get a plausibility estimate. So, okay, so this is our line 4x plus 4y equals -3. Where do these lines cross? At this line and this line. Okay. Now this line for x is a little closer to 0 than 1, so I'm going to approximate this. It's a little less than half, so I'm going to estimate 0.4. Now look at our approximate value of x when we solve the simultaneous equation. Okay, I just lucked out and got 0.4. I was thinking I was going to be 0.3, but it's 0.4. Okay. So, it's not 0.4. 13 over 32 is not 0.4. Yeah, it is. Never mind. Okay. This is, well, here's x equals 1, -1. Here's x equals -2. This looks to me pretty close to x equals -1.1. Now, I've written that pretty small, but my point is my estimated solution is -0.4, -1.1, and the more accurate solution is 0.4, -1.16. In other words, my graph agrees quite well, better than I could ever expect, with my solution. So part of the problem, and when you're tested on this, I want to see all this. I want to see all these steps with the fractions. Then I want to see 2 good graphs and a decent estimate. Okay. There we have it. Okay. Now I'm going to show you another way to solve these two equations. I'll use the same equation. And we should get the same solution if we do all the steps correctly. And this involves even more fractions. And we don't want to use decimal equivalents because there's almost always a round off error. And sometimes that round off error throws everything all haywire. Sometimes it doesn't make much difference, but sometimes it can really be, it can really give you a bad solution. Okay, so we're going to start with 3x minus 5y equals 7, and 4x plus 4y equals negative 3. And I'm going to do a couple of operations here. You might be a little mysterious when I do them. Okay, the first equation, I'm going to divide everything by 3. Okay, so I'm going to get x minus 5/3 x equals 7/3. Well, here are my dreaded fractions. We're going to have to live with them now. Okay. It simplifies some things and makes other things more complicated to deal with the fractions. Okay, so can you read that? This is going to be equation 1. Not this equation 1. This is the equation 1. We looked at the last step for number 1. Okay. And then we do equation 2 minus 4 times equation 1. The other thing we do is we don't do any of the arithmetic here because we want everything to proceed one step after another without a bunch of arithmetic in the middle. So over here, we're going to write down equation 1. Actually, we're not going to write down equation 1. Okay, we're just going to do you know, I want to put my circle around the 2 after I write the 2, not 4. Okay. Equation 2 minus 4 times equation 1. Now, what do you do if you do equation 2 minus 4 times equation 1? How are you going to get that? Well, first, you want to do minus 4 times equation 1. So, can you fill this in? What's minus 4 times this equation 1? Because we're in this step here. Okay, we got a question. Might mean I made a mistake. Boy, I'd hate that. Okay, so the question is basically, how did this y become an x here? Okay. If we divide 5y by 3, we get 5/3 y, not 5/3 x. That's absolutely right. So thank you for that correction. We definitely want to get that correction right. Okay, so again, now, what's minus 4 times equation 1? And then do whatever you need to calculate equation 2 minus 4 times equation 1. Okay, minus 4 times equation 1 would be minus 4 times x minus 5/3 y equals minus 4 times 7/3. Writing that kind of small, but it gives you minus 4x plus 20/3y equals negative 28/3. over 3. Is that what you got? Kind of looks like what you got. I mean, I didn't absolutely check it. Okay, so now what's it say to do here? It says do equation 2 minus 4 times equation 1, right? Okay, well, here's equation 2. Okay, so I write down equation 2. Here's 4x plus 4y equals -3. That was one person wanted to multiply this by -4, but there's no -4 in front of equation 2. Okay? So we just write down equation 2. And then it's -4 times equation 1. Well, we just figured out what -4 times equation 1 is. It's -4x plus 20 thirds y equals -28 thirds. Okay. So when we put these together, here's -4. Times equation 1, there'll be a minus in front of the 4x. So if we add these two together, what do we get? Now this does get to be a little bit of a mess because we have the fractions. Okay, now everybody's had time to engage the problem. First of all, 4x minus 4x is going to give us 0, right? Now 4y minus 20 thirds y, we got room to scratch over here, okay? 4y minus 20 thirds y equals 12 thirds y minus 20 thirds y, which equals -8 thirds y. Okay, we just multiply the 4 by 3 over 3, and we get 12 over 3. Okay, we just put it over common denominator and add. And we can't at this stage do the slick thing we do with equations and multiply both sides by the common denominator because we don't have two sides. Okay. If we, well, no, okay. And we do the same thing over here. -3 is -9 thirds. I'll scratch it out here. There's no y. I don't know why I put a y on there. Because I saw a y there. But -3 minus 28 thirds is -37 thirds. So we get -8 thirds y equals -37 thirds. And the problem with my 8y is I subtracted 20 thirds. I'm supposed to add 20 thirds. So it gives us 32 thirds, sorry. And it's not negative. So this ought to be 32 thirds here. Accidentally subtracted where I should have added, but you see how you add them, right? Use a common denominator. Add 4y, 20 thirds y, you get 32 thirds y, which is obvious if you look at it and you're on cross-eyed. So what do we get? We get y equals -37 thirds. Okay. Now I've gone one step too far, but I'm going to write it over here. I did my scratching over here. I'm going to write the system. Okay. Equation 1 is going to go here. It's, yeah, equation 1's here. and 2 minus 4 times equation 1 is here. Okay, so here's equation 1. Well, here's our new equation 1, here's our new equation 2. I can rewrite these like so. Bring down equation 1. Equation 2, we can solve. Leave myself room. Actually, I'm going to write it out as a multiplication. Okay, I multiply this by the reciprocal of 32/3, which is just going to give me y. And we get negative 37 over 32. So we've got a solution for y. Now, what we've ordinarily done is we've taken this solution and substituted it into one of the original equations. We're not going to do that here. We're just going to solve it into the existing equation, or we're going to substitute it into the existing equation 1. So we substitute y into equation 1, we get x minus 5/3 times negative 37 over 32 equals 7/3. So now all we've got to do is do the arithmetic, and we've got our solution for x. We're going to get x times 185 over 96 equals 7/3. So we get going to be negative 185 over 96 plus 7/3. And that should come down to 13 over 32. And I kind of think it does. Okay, you can check out the arithmetic of this, but if you multiply numerator and denominator here by 32, you get 225 and minus 185. And that's over 96, and that reduces as it did here to 13 over 32. So all the fractions come out the same. What's the advantage to doing this? It's a lot more work, isn't it? Kind of a pain. But there's also kind of an elegance to the way the equations evolve. Okay, first of all, we get a 1 in front of x here. So that's y divided by 3. I just want to have x here. That way it's easy to see what multiple of this thing, what multiple of equation one here, we would add the equation two. It's going to have to be minus 4 times this to match up the minus 4, the 4 and the minus 4. So we bite the bullet, we go through the arithmetic, and then we write down the first equation just as it is. We write down the second equation, the one that we got when we did equation 2 minus 4 times equation 1. And then it's just a matter of dealing with the fractions to solve this. We keep equation 1 there because once we've solved this, we put this number back in for y and we get an easy solution for x. Now, the reason we've done this, well, I'm going to show you. Okay, skip down to that last step because you want to do one more thing. I want to take time to come think with that.
Well, I'm trying to figure out what you're doing. Because I don't because we didn't do that we didn't do that in the episodes last time.
Well, it mimics what we did. Give yourself another couple sets of brackets, then write down that last set of brackets, because I want you to see how that last step works out. Okay, so give yourself room to put all the rest of it in there. Again, we're doing row 1 here, plus 5/3 of row 2. If you've been watching me, you know I'm just looking at one number at a time. I'm going to take 5/3 of whatever's in row 2 and add it to whatever's in row 1. And there are only 2 numbers to work with. You got the 0, that's going to give you 0. Can you copy that down?
They can check his test rate.
Right here is what we want to focus on. Got this, which is thanks what we got here. I haven't written any of this stuff down because you don't need it to do this stuff. Everything that might be confusing, I've eliminated, so we just need to do this one step action.